Hello friends, this video on application of derivatives part 18 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 17. Let's learn how we'll use derivative to find maxima and minima of a particular function. Application of derivative to find maxima and minima of a function. So in this whole chapter, we'll use the concepts of derivative to find maxima and minima of a function. To find maxima and minima, you have to find turning points of the graph. The turning point of the graph generally will give you maxima and minima. Also, we can find the absolute maxima and minima of a function. We'll tell you what is absolute maxima and minima and what is local maxima and minima. Just to start with, let's give you a fair idea. If this is my function and this is an open interval function, open interval in the sense I don't know what is the domain, starting point and end point. I don't know. There is some function and it has, let's suppose the domain is all R, all real number. In that case, my function is like this. I don't even know what is the starting point and end point. So in such kind of functions, we generally find the turning points if it is differentiable. If differentiable, and please note the derivative can be used only when the function is differentiable. So if it is differentiable, you find f dash x, and if that is equal to 0, that is the turning point. Why? Because at all these points, if you see, my slope is 0. All these points, you see. So the maxima, the local and maxima and minima in such case will be at the turning point only. If you see, the turning point, the slope is 0. So the first thing we can do is, if you want to find the maxima or minima, local maxima or minima of the function, you can just find turning points where it is, where the slope is 0. Once you have a turning point, you have the critical points actually, and then you can find whether that point is maxima or minima. Or we have other better way also to find that. We'll learn that, but just I'm trying to show you how to find local maxima and minima. The moment you talk about absolute, I talk about closed interval, because see what happens is, if I have my function like this, we have two turning points, but if you see, the maxima is still this. It is not the turning points. The maxima is the end point. Maxima can be an end point, but when you talk about open interval, there is no end points, right? Because it says the domain is all R, there is no end point. But if you say in this case, suppose the domain is 1 to 2, so you have end points. The moment you have end points, you can consider end points, and then you can give the absolute maxima and minima. See, the local maxima and minima is nothing but the one which you get from turning points. And the absolute maximum and minima is which you get by considering even endpoints also. So this is the difference between local maxima and minima and absolute. The only thing is, when you talk about local maxima and minima, you talk about the open interval function where you can't consider the endpoint because open interval. And you talk about absolute maxima and minima, you have the endpoint also. So you can consider the endpoints. So before we go more into this and break our head, let's understand first the real life application of maxima and minima, and then I'll explain all this to you step by step. I'll take more examples to clear the concept. This was just an introduction of you can say derivative and a differentiation between the local maxima and minima and the absolute maxima and minima. In the absolute maxima and minima, we have the closed interval, so we can consider endpoints. In local maxima and minima, it's open interval, so we can't consider. So let's say take some real life application of maxima and minima. You have this factory and you produce some goods actually, let's suppose, and the cost of some product Px is determined by some formula, let's suppose ax square plus bx plus c, where a, b, c are some variable costs. For example, cost of labor, cost of electricity, cost of raw material, something like that. So if I have the formula, I want to find the maximum cost or the minimum cost. What is the maximum cost of the goods? Or what is the minimum cost of the goods? How can I optimize? Such kind of stuff we can use maxima and minima. If you are standing and there are enemies in front of you, and they are standing in some particular path, right? With that path, if you want to find distance, right? So if you know the function of this path, let's suppose fx y is equal to fx some function, and if you can find the distance also in a function, then with the maxima and minima you can find which is the nearest enemy whom I can shoot, because this guy is far, this is near. If you want to find who is the nearest enemy, you can use that. So in military purpose also they use sometimes maxima and minima to find which is the nearest target, so that we can hit the nearest target easily. If you have a ball, let's suppose you want to throw the ball, it goes up, it comes down. There's a maximum value, it goes up, right? And then it comes down. You have to find the maximum point, the maximum peak where it reached. You can use here also the maxima and minima. You have the sales trend graph or the profit graph. It's already in the graph. You want to find the maximum profit. Let's say it's a profit graph for a per company. You want to find the maximum profit, minimum profit. Such kind of stuff also you can do using maxima and minima. You have this square shape, let's suppose square or rectangle shape aluminum plate, right? And now with this you want to make a cuboid or cube. So if you see, you can make like this, you can cut this in this fashion, and then you can fold this guy. If you fold this guy, if you take this guy up, this guy up, this guy up, this guy up, this anyway vacant. So what you get is this kind of figure, right? So here also if you see, we can use maxima and minima if you want to find the maximum volume of the cuboid or the maximum surface area. Those kind of stuff we can use maxima and minima. So a lot of places in our real life we can use maxima and minima actually. So if you have, let's suppose, one big sphere, from this you want to make small spheres, right? And you want to find the optimum area with which the maximum surface area is there for the total small surface, a small sphere. In such case also we can use maxima and minima. So these are some real life application of maxima and minima in our real life. So let's understand the terms used first before we go to the topic. If my f is a function on interval L, and then f is said to be a maximum value if there exists a point C in this L, the C is a member of L, where you take fc, that guy has to be greater than or equal to any point fx, any point for all fx, any fx, that guy is greater, then that guy is called, fc is called maximum value and C is called point of maximum value. For example, this is my graph. If you see, this guy is called C and this guy is called fc. So this guy is the maximum value. So you take any point in this graph fx, any point, you take this guy, this guy, this guy, this guy, fc has to be greater than any of these points. So this is called maximum value. Fc is called maximum value and C is called point of maximum value. Similarly, in case of minimum also, same thing. Let's suppose this is C1, this is C2, let's suppose. So this guy is nothing but f of C2. This guy is the minimum value. Why? You take any point in this graph, f of C2 is less than f of x. You take any x. So C2 is called the minimum point of minimum value and f of C2 is called minimum value. And then there is something called extreme value. Extreme value is nothing but a general term for maximum and minimum value. So if you have this kind of function, if you see, so both are extreme values. The way we find is, to find extreme value is very simple. You just differentiate this guy. If the slope is 0, that is extreme value. Correct? So extreme value is a general term for maximum and minimum value. Also we'll learn that it is extreme values happens not only at slope 0. There are other places also. For example, see, this was anyway, we'll discuss those things. I'll tell you if you want. This is my graph like this, right? So this is also, if you see, the maximum and minimum. These are also extreme values. Sometimes the graph is not differentiable, and then if you see, the graph is something like this. If you see this point, the graph is not differentiable. This is fx is equal to mod x. At this it is not differentiable. Here also extreme points can lie. So extreme value can either lie at f dash x is equal to 0, that is turning point, not differentiable area, where the points where the graph is not differentiable points, or my end points. So these are the points where actually I can have maxima or minima. Correct? So extreme points are nothing but a general form of maxima and minima. So extreme points can be maxima, extreme point can be minima. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.